Welcome to Physics World Online College, where simplified physics is presented to you for you to understand, learn, and also excel in your exams. In our class of today, Physics 101, we will consider an alternative form of finding cross product of vector products, which is the matrix method, or using matrix form. Here, the determinant of the matrix represents the cross product or the vector product of the two vectors. Now, this is a follow-up on the last class where we did scalar multiplication or vector or dot product. In that case, you multiply two vectors to obtain a scalar quantity. Here, we multiply two vectors, we call it the cross product, to obtain a vector quantity. So we are going to get a new vector after multiplying or crossing two vectors. Please remember to share this class video with your friends and then post it on your Facebook page, your TikTok, and then Instagram and other social media handle that you have, so that others will be aware of what is happening in this platform. So we continue with our discussion. An alternative method of finding the cross product or vector product of two vectors is by using the matrix form. By using the matrix form, where the determinant of the matrix represents the cross product or vector product of the two vectors. Now, let's consider two vectors A and B. Let's consider two vectors A and B, such that vector A is equal to ASI, AYJ, AZK, and vector B is BSI, BYJ, BZK. For us to find the cross product between vectors A and B, A and vector B. You remember that order is very important in vector multiplication. So we find the cross product of vectors A and B, meaning A comes first before what? B, or A cross B. Now, to make it align with this discussion, I'm going to add to this question using matrix or determinant method. Using matrix method or determinant method Now, how do we achieve that? So solution to the example we have now is I'm going to represent vector A cross B in matrix form as the vectors A cross B can be put in matrix form as, can be expressed, let me use the word express, in matrix form as A cross B equals, I will use this sign, absolute sign here means determinant. We'll take the unit vector I, J, K, and then I will put the coefficient or component vector. So this is AX, AY, AZ, and the B, BS, BY, BZ. Now, this is a 3 by 3 matrix. This is a 3 by 3 matrix. And to obtain the determinants of this matrix, so I'm going to explain some of those steps in matrix method. So you will learn it together with this cross product. So I said the determinant of the above matrix, is obtained or given by, now I'm going to reduce this 3 by 3 matrix to a 2 by 2 matrix. How will I do that? There's what we call the positional sign of every members in this matrix. Now, this unit vector I, J, K are in the first row of this matrix. Now, I is on the first row and first column of this matrix. And the positional sign for that, any element or number here is minus. Then this is first row, second column. Oh, sorry, this one, first row, first column is plus. First row, second column is minus. First row, third column is what? Plus. So that positional sign continues. So this is plus, minus, plus, minus, plus, minus, plus, minus, plus. Good and fine. So I'm going to apply it as I work. So I'm taking the first unit vector. Right now, I'm going to reduce this 3 by 3 method to what? 2 by 2 method. How do I obtain that reduction? Take note. I'm going to, in this first element, this unit vector I, I'm going to draw a line vertically and then a line horizontally. So like I'm eliminating all these components. If you close this, that's the row for that I. If I close it this way, that's the column for this I. So what I will have left will be what? These elements. So I'm going to take them as AY, BY, AZ, BZ, multiplying the unit vector I. Then I'll take the positional sign. There's a plus here for this already, so it's not normally written, but it's implied. So I take the positional sign minus. I will reduce the matrix also. This is the column for J. This is the row for J. The element not involved. If I close this and I close this, you will see the element not involved will be what? AX, BX, and AZ, BZ multiplied by what? J. Then the positional sign for K is plus. I will reduce this row and column. So this is the what? Row for K. And this is the what? Column for K. So what are the elements remaining? You have AX, BX, and you have AY, BY multiplied by the what? Unit vector K. Good. So I have reduced this 3 by 3 matrix to what? A 2 by 2 matrix. In further matrix calculation, this 2 by 2 matrix, to find the determinant of this 2 by 2 matrix, I will use this element to multiply this one minus, I will use this element to multiply this one. That will give me the answer. So this becomes A cross B is equal to, observe what I'm doing, AY times BX, AY BZ, AY BZ minus AZ BY, AZ BY multiplied by the unit vector I. Likewise, I take this minus, I will use AX to multiply BZ. So I have AX BZ minus AZ BX, AZ BX to multiply J. Then plus, I have AX times BY, AX BY minus AY times BX, AY BX multiplied by what? The unit vector K. Now, because I want this to align with the general expression as with the previous method we use to obtain the cross product, I'm going to change this minus to plus by rearranging the component inside. So this will become A cross B equals, I have AY BZ minus AZ BY multiplied by what? Unit vector I. Now this minus, I'm changing it to plus. What will I do? I will interchange this position. So that will give me, this becomes what? A. This becomes AZ. That becomes, okay, that's plus AZ BX. Then minus AX BZ multiplied by what? J. Now, if you look, if I open this bracket, I will obtain this function the same. So this will be plus AZ BX. That is because minus times minus gives you what? Plus. And then this will be what? Minus AX BZ, which is this component. So we are okay. Then this last one, plus AX BY minus AY BX K. Now, to confirm that what I have obtained is correct, I'm going to compare it with this standard. So A cross B equals AYBZ minus AZBYI. That is correct. Plus AZBX minus AXBZJ. That is correct. Plus AXBY minus AYBX. K. That is also correct. So my derivation is right. Now, I'm going to apply it now to solve this example. And once again, you will confirm that we have the same answer. So whether you use this determinant or matrix form, or you decide to use the previous one, that expanded form I obtained in the last class, you will discover that you will have the same answer. So the decision is yours. But this method is pretty straightforward for students to solve. So you find them using it more for solving cross product or vector products. So we have solution to example, solution to example, solution to example. So we are given the two vectors, vector A equals 3i minus j plus 3k, and vector B we are given as minus j plus 2 minus I plus 2j minus k. Good. So once we compare this with the general equation, as you know, it means AS is what? Is 3. It means AY is minus 1. And then AZ is 3. So this gives us that AS is 3, AY is minus 1, AZ is what? AZ is 3. So we have AZ as 3. Likewise, BX is minus 1, BY is 2, and BZ is minus 1. So now we can put it in matrix form. We're asked to find the cross product between A and B. So which means A comes first. So we are looking for A cross B. Now we put it in the matrix form. We have determinant of I, J, K. And then we have AX, which is we have 3, minus 1, 3. We have minus 1, 2, minus 1. So we're solving with the matrix form in this case. So we reduce it to what? 2 by 2 matrix. Please remember the positional sign. If you miss out the positional sign, there is no way you are going to get the correct answer. So let's do that. I reduce it to 2 by 2 matrix. Give me A cross B equals, this is plus, this is minus, this is plus, plus, minus, plus. The positional sign, you must know it is there. Nobody will write it for you, but you must know it is there. Hence, I've explained it to you. So I reduce it now to 2 by 2 for the I. I have, if I eliminate the row and column, I will have minus 1, 3, 2, minus 1 remaining to multiply by I. Then this positional sign minus, I reduce the J, row and column. I have this. What I have left, we have 3, 3, minus 1, multiplied by what? J. In like manner, I will reduce for the k. We will have that plus, that's the positional sign. We have this and this row column. What I have left, 3 minus 1 minus 1, 2, multiplied by what? K. So now we reduce this 2 by 2 matrix to now give us A cross B equals, remember, I will have minus 1 times minus 1, then minus 2 times 3. Multiply, that gives you I. Then minus, I have 3 times minus 1 minus 3 times minus 1. That's this times this. J plus, I have 3 times 2 minus 1 times minus 1. Then K. So we have reduced it further. Now we multiply out the values that we have. That will give us A cross B to be equal to minus 1 times minus 1 is 1, minus 2 times 3 is 6, I, minus 3 times minus 1 minus 3, minus at the center 3 times minus 1 minus 3, multiply by J, plus 3 times 2 is 6, minus 1 times minus 1 is 1. So that gives us 6 minus 1, K. So this will give me further that A cross B is equal to 1 minus 6 is what? Minus 5I, plus minus 3, minus times minus is plus 3J, plus 6 minus 1 is what? 5K. So this gives me A cross B equals minus 5I minus 3 plus 3 is 0. That's minus 0J plus 5K. So that will give us further that A cross B is equal to minus 5I plus 5K. If you check very well, this is the same as the answer we got for the last class. So that confirms that whichever method you use, you will still arrive at the same answer. Now, there is a law that we want to confirm. So we are asked to find, option B says, find the cross product of vector B and vector A. That is, if B comes first before A, to check whether you will get exactly the same answer. You will see, no, you are not going to get the same answer. So let's take that. Solution B. We'll take solution B. So let's take that. Solution B. I think I have to clean up this so that it will be easier for us. So solution B. Now, B cross A means B comes first before A. Means B comes first before A. So I have option B says find B cross A. That will give me, you put the unit vector I, J, K, and then the vector B first. That is minus 1, 2, minus 1. Then A, 3, minus 1, 3. That's a 3 by 3 matrix. Next, I will reduce the 3 by 3 matrix to what? To 2 by 2 matrix. That will give me that B cross A is equal to, remember the positional sign, plus, minus, plus. So that gives me, I reduce the row and column. What do I have left? 2, minus 1, minus 1, 3. Multiplying what? I. Minus, I reduce the row and column. This and this, I have minus 1, 3, 3, J. Positional sign plus, I reduce the row and column. I have minus 1, 2, 3, minus 1, K. Now, I reduce the 2 by 2 matrix further, and that gives me A cross B equals 2 times 3, 2 times 3, minus 1 times minus 1, I, minus 1 times 3, minus 1 times 3, that's J, plus, I have minus 1 times minus 1, minus 3 times 2, K. So that will give us that B cross A is equal to 2 times 3 is 6, minus 1 times minus 1 is 1. That's I, minus 3 times 1, minus 1 times 3, minus 3, minus bracket, minus 1 times 3, that's minus 3, J, plus minus 1 times minus 1, that is 1, minus 3 times 2 is 6, that's K. So we have that B cross A is equal to 6 minus 1 is 5, I, minus, this is minus 3, minus times minus is plus 3, I, that's J, plus 1 minus 6, that's minus 5, minus 5K. So this will give us that B cross A is 5I, minus 3 plus 3 is 0J. And this plus times minus 5K. That gives us that A cross B, B cross A is what? 5I minus 5K. If you check, you will see that this answer is not the same as A cross B. There's a kind of change and an interchange between the signs, so they are not the same. So what is this confirming to us? This shows that cross product is not commutative. It shows that A cross B is not equal to B cross A. So we are saying that the cross product is not commutative. This shows that A cross B is not B cross A. So hence cross product or vector product is not commutative. So assuming A cross B is B cross A, we say it is what? Commutative. Does not obey commutative law. If it does not obey commutative law, it will also not obey distributive law. So let me just add that for want of time. Cross product is not commutative and also does not obey distributive law. Law. So it does not obey commutative law and also does not obey distributive law. Good and fine. Meaning order is very important. So if they say find A cross B, if you do B cross A, you are wrong. Now, we have an assignment here for you to do. Please do this assignment and post your answer on the comment section. Remember to share this class video with your friends. Bye for now.